In this brief presentation, I'd like to discuss some Math GED/HiSET specific comments that you may find useful as you prepare for teaching this course next semester. Before making math specific comments, I want to point out that in my classroom, I plan to have one or more of three primary activities taking place on any given day. First, mini lectures, and coupled with, secondly, some workshop problems where I will give students problems that reinforce the concepts covered in a mini lecture or lectures if I do more than one during a given period. Another thing I may do is I might take the whole period to have students do problem solving sessions or workshops. And then thirdly, I might just go ahead and go early to the lab, or I might use the whole period to go to the lab. So you might want to keep those in mind as three different ways of using your time in a flexible manner in the classroom. The first math-specific comment I'd like to mention is the key guiding principle that I intend to use in my classroom. And that is that it's going to be more important for me to guide my students on how to pass the math test than it is for me to try and teach them all the mathematics associated with the test. Obviously, as a math teacher, I'd love to teach them all the mathematics, but I just don't have enough time. And to be honest, neither do they. So I'm going to focus on estimation techniques. I'm going to focus on guess and check techniques, especially since they have multiple choice answers they can use for their guesses, and other related techniques that are applicable to multiple choice tests. So let's take a look at some examples of how I see this playing out. Here's a sample no calculator problem from the GED Ready Mathematical Reasoning Test. Multiply 2 7/75 times 1 2/10. Now, I could go ahead and multiply that out using multiplication of decimals, but notice I've got 4 answers already given to me. What if I could find a way to cut down my work so I don't have to multiply 2 7/75 by 1 2/10? For example, let's just go ahead and say 2 7/75 is roughly 3, and 1 2/10 is roughly 1. So this is going to be approximately equal to 3. Now I take a look at the answers that they gave me. 825 thousandths, nope, no way is that going to be the answer. 3 3/10. This looks promising. I'm going to circle it because this is a very good likely answer in this case. 8 25 hundredths, no way. 33, not even close. I would check this answer off as being the correct one without actually having to do the multiplication. For our second example, let's see how we can apply guess and check techniques on a multiple choice test. And the problem we're given in this case is that we have a guy named Justin. He's exchanging dollars for rolls of quarters. And I'm going to go ahead and underline that, or actually I'll circle that because that's kind of important. Quarters, and then rolls of dimes. And I'm going to go ahead and exchange some money for rolls of quarters and dimes at a bank. Each roll of quarters has a value of $10. I'm going to circle that. That seems important. And each roll of dimes has a value of $5. All right, circle that. I'm going to exchange $90 and receive back 11 rolls of coins. Now, taking a look at the 4 multiple choice answers that are given, I can see that A, 4 plus 7, that's 11 rolls of quarters and dimes. 7 plus 4 is 11, 5 plus 6 for answer C is 11, and D, 6 plus 5 is 11. So all 4 of the answers give a total of 11 rolls of quarters and dimes. So that doesn't help me out at all. So the next thing that we're going to go ahead and do is start checking each of these answers for their value. So for example, for A, I have 4 rolls of quarters, so 4 times 10, that's going to be $40 worth of quarters. For the dimes, I have 7 times, each roll of dimes is $5, so I have $35 in 7 rolls of dimes. That's a total of $75. That's obviously not enough. So I'm going to go ahead and say that answer A doesn't work. Let's go ahead and erase all the ink on the slide. Let's try answer B. So here I have 7 rolls of quarters. That's 7 times 10, $70. And then 4 rolls of dimes, 4. Each roll of dimes is $5. That's going to give me a total of $20 in dimes. 70 plus 20. That works. So answer B 7 rolls of quarters, and 4 rolls of dimes is obviously the correct answer in this case, which I found by just using the answers as my means of checking which one works. Now I could go and check answer C to see if it works and answer D, and I would find in each case that I get a different value of money, total value, and so answer B does wind up being the correct one in this case. For the third and last example of how we can use both guess and check and calculator techniques for multiple choice tests, I'm going to show how we can solve a linear inequality by simply considering the left and the right hand sides of the linear inequality separately by plugging in different values of x in order to eliminate choices that are given by the 4 multiple choice answers. I'm going to do that on the next slide, but I want to also point out before going to the next slide that this technique can be used with linear equalities where you have an equal sign instead of an inequality symbol. The same techniques that I'm about to show for solving this linear inequality can also be applied there. For my third and final example of comments related to instruction in the math classroom, I want to go ahead and show how we can solve the linear inequality I had on the previous slide using some guess and check techniques as well as the calculator. So to begin with, taking a look at the left-hand side, I look at the 4 answers that we have given as examples A, B, C, and D, and by using a well-chosen number, I think we can eliminate a couple of these possible answers. So let's try x equals 0. For linear inequalities, that is always a great choice to try. It eliminates stuff very quickly. So looking at the left-hand side of the inequality, 4 times 0 is 0, so that's going to go away. And that will just leave me with -3 times -8 and 2/10. On the right-hand side of the inequality, -11 and 98 times x is also going to be 0, and that's going to leave me with just 14 3/4. And so the question is -3 times -8 and 2/10 going to be less than 14 3/4? Well, this is roughly 24. -3 times -8 is about 24, and I can already see that is not going to be less than 14 3/4. So 0 doesn't work. That means that answer B is not correct and answer C is not correct since 0 is less than both of those choices, 49 2/5 and 492.5. Now I only have 2 possible answers I need to worry about. Either x is greater than 49 2/5 or x is greater than 492.5. So let's pick a value of x that's greater than this but less than 492.5. I'm going to just randomly choose x equal 100. I could choose any value I want that's greater than 49 2/5. Now we get out our calculator. I'm going to use that to evaluate the left and right hand sides of the inequality. Now in doing so, let me go ahead and adjust this just a bit. Let's turn the calculator on, clear it out. It's always a good idea to make sure your mode is in math print because that will allow us to enter in the value 14 3/4 just like it appears on the paper. And so now I'm going to go back and do the left hand side of the inequality. So -3 parentheses 4 times 100 minus 8 2/10. When I hit enter, I get -1,175, so -1,175 and 4/10 on the left-hand side of the inequality. And now I'm going to do the right-hand side of the inequality, so -11 and 98 times 100 plus 14 3/4. Oops, let me go back and change that, so delete that and use the mixed number key 14 3/4 and go down using the cursor key. I hit enter. I have -1,183 and 25 and the question is -1,175 and 4/10 less than -1,183 and 25 and the answer is no, it is not. This negative value is closer to 0 on the left-hand side of the number line than this one, which means that it is a greater value. So I now know that answer A is not correct, and therefore answer D must be the correct one. Now, if you're not convinced that answer D is correct, you could go back to your calculator and double check by picking a number that's greater than 492.5 and see whether or not the left-hand side is less than the right-hand side of the inequality. And I'm going to go ahead and do that just for illustration. On a test, I would never actually do this because I wouldn't have enough time. But here I'm going to do it for illustration purposes. So let's go back and check for x equals 500, which is bigger than 492.5. And I can use my calculator to do that very easily by just replacing the 100s with 500s. So I'm going to do the left-hand side first. Notice I've moved my cursor up to that entry where I had entered 100 for x before. I hit enter. It copies that line down below. I can change the 100 to a 500, hit enter, and I now have that that's negative 5,975 and 4/10. And again, I'm asking the question, is that less than the right-hand side? And now I go ahead and I go up to the right-hand side of the inequality again where I had 100. I hit enter, it copies that down below, and I can now go over, change the 100 to a 500, and I get this, negative 5,975. Oop, there we go, 75. I miswrote that, and 2500ths. And it turns out that negative 5,975 and 4/10 is less than negative 5,975 and 2500ths. This is true. And so therefore now I'm convinced that my inequality answer is x greater than 492 and 5/10.